Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we'll go over 2021 AIME 2 number 14. So in this problem, it states, let triangle ABC be an acute triangle with circumcenter O and the centroid G. Let X be the intersection of the line tangent to the circumcircle of triangle ABC at A and the line perpendicular to GO at G. Let Y be the intersection of lines XG and BC. Given that the measures of angle ABC, BCA, and angle XOY are in the ratio 13:2 to 17. The degree measure of angle BAC can be written as a fraction. So we want to find the degree measure of angle BAC. So to save us time, I already drew a diagram for us over here. So I will just paste it in over here. As you can see, we have a triangle ABC with the circumcenter centroid things that it's stated in the problem. And if we take a look at that, we have a tangent line at A. That naturally leads us to connecting A and the center of our circle. So connecting AO, let's see if we can get something out of this. So if we connect AO, then we see, oh, okay, yes, we can, there is a right angle here, and there's a right angle here, meaning, cyclic, right? So we have already a cyclic quadrilateral. So let me draw in the circle. You don't actually need the circle to proceed, but just for conveniences, I will draw in the circle just for us to see it better. Let me resize this. It's obviously not perfect because I hand drew this diagram, but we can pretty much see this is a cyclic quadrilateral. There we go. So now, oopsies, now we can take a look. So, we know that this is 17x, right? Let me just label in. This is 17x, this is 2x. Now, this has this side. It's kind of hard to work with. So maybe we want to put our focus into this triangle XOY. Maybe we can find the other two angles, and then we can maybe do something on those lines. So to find this angle, we see, because we have a cyclic quadrilateral, now it's natural that we connect AG. Then we would have this angle up here is equal to this angle down here. So angle GXO is equal to angle GAO because they subtend the same arc. Now we already have AG. What is G? G is the centroid. So what's the next natural thing to do? That's right. We can extend this G to this point, also known as the midpoint. So this is the midpoint of BC, and if we just just draw OM, we would know that this is the perpendicular bisector because O is our circumcenter. All right, now we have a triangle. Naturally, we have one right angle here and one right angle here, so we can see there is another cyclic quadrilateral over here for us to use. So let me just be careful here a little bit. So now we just want to find the other side, right? Let me fill this in. We just want to find this angle over here. And this angle over here by our cyclic, it's equal to this angle over here. So now if we put our attention to this triangle AOM that I kind of highlighted over here, we can see that two of the angles correspond to the big triangle XOY. So actually, AOM is similar to XOY. And that is really good news for us. We can, let me just change another color, know that this angle here is 17x. Now, if this is 17x, let's just take a look at our quadrilateral ABMO, this quadrilateral over here. We know three of the angles. We technically not know them, but we have expressions for three of the angles over here. So we can just have this angle is 360 degrees because that's the sum of the internal angles of a quadrilateral minus this 17x minus 30x minus this 90 degrees. So that is 270 degrees minus 30x. Now we would have easily this. How does this help us? Now we have this angle to AO. That seems a bit strange. How about let's connect the other two? This BO and this CO. All of these are the big radius, the radius of the circle of ABC. So all of these triangles, ABO, ACO, BCO, all of these are isosceles. So this angle right here must also be 270 degrees minus 30x. So this angle right here is 13x minus that above, or 43x minus 270 degrees. Similarly, this is 43x minus 270 degrees, meaning that this is 2x minus that. Or we would have 270 degrees minus 41x. And here, similarly, we would have 270 degrees minus 41x. So this angle A, or angle BAC, in total, this angle, giant angle over here, this is 540 degrees minus, that is 71x. A very big number, but we are almost there. Now we could just use the sum of the internal angles of a triangle. So 540 degrees minus 71x plus 13x plus 17, plus 2x is equal to 180 degrees. So 56x is equal to 360 degrees, or x is just equal to, let's just cancel out a 4 right now, 90 degrees over, that is 14, or we would have 45 degrees over 7. Now, to find the 540 degrees minus 71x, we just need to find 540 degrees minus 71 times 45 degrees over 7, or 7 in the denominator, 540 degrees times 7 minus 71 times 45. Have to do this calculation very carefully. We are almost there. And this is 71 times 45, 355,284, 3195. So 3780 minus 3195 over 7, or this is 585 over 7. It wants us to add the numerator and the denominator, so 585 plus 7, which is equal to 592. And that is our final answer for this problem. You can see that there's not really any advanced techniques used in this problem. And if you stare at it long enough, you might be able to. The only hard thing I would say in this problem is to find the two cyclic quadrilaterals. But even that does have semi-clear intentions in leading you to those steps. So that is number 14 in 2021 AIME 2, and I will hope to catch you in the final video of 2021 AIME 2, the grand finale number 15. But for the time being, have a great day and goodbye.